Hey everyone, welcome to Chapter 12, Section 1. I do go over a little bit of Chapter 1, Section 7 because it relates well to this topic. Here I'm going to go over three-dimensional figures. The first thing to go over is the difference between a prism and a pyramid. A prism has two bases, and you call that prism whatever the bases are. So this one, this picture right here, that's a pentagon on the top and bottom. So this is a pentagonal prism. And in a pyramid, we'll have one base, whereas the other had two, and all the edges will meet at a singular point at the top, at that vertex. And yeah, so just picture a pyramid, but you can have whatever kind of base you want. And then you know that a cylinder has bases of circles, and then a cone has almost like a triangle with a circle, and then a sphere, you know what a sphere is, it's a ball. So we talked about definitions of polygons in the past, and a polygon is something with comprised of any number of edges. It can't have any curves, and as long as it's closed, it's a polygon. So a polyhedron is a three-dimensional object composed of polygons, and it just can't have any curves. So I'm gonna determine whether each one is a polyhedron. I'm not gonna identify the bases, faces, edges, and vertices. That's a lot to write down. I think it's okay to just go over, is this a polyhedron or not. So to save time, I've typed this out beforehand. So yes, this is a polyhedron. There's no curves, and this is a rectangular prism. The next one is not a polyhedron. Why? Because it has a curved surface, and but that is a cylinder. I know that's a cylinder. This one, see how this is a pyramid? They all meet at point D, and it's a triangular pyramid because the base is a pyramid. On ED, excuse me, this is not a polyhedron again because it has a curved surface, but it is a cone. And then on part E, this is a prism, and it's a triangular prism. So if you ever get confused, just look at these examples C and E, between what's the difference between the two. All right, and that's it for the front. The back is going over Euler's theorem. It's spelled Euler, but it's pronounced Euler. And it's this F plus V equals E plus 2. So that means you can count all the faces in a three-dimensional object. This has 6 faces. And then you can count all the vertices, or the corners. And this has 8 corners. And it's going to equal to the edges. The edges would be the lines, plus 2. And that's true for any three-dimensional, like regular three-dimensional object. So in this first one, I'm counting all the faces, and I have 6 faces. I count all the corners. I have 8 corners, so that's 8 vertices. So 6 plus 8, that's 14. So when I count my edges, it should be equal to 2 less than that. So it is equal to 12. If you count all the lines, it's equal to 12 edges, and 12 plus 2 is also 14. So that's how you would check it using Euler's theorem. So on this V-shaped prism, we have 9 faces, 14 vertices, and again, you could just find this stuff out by counting. I counted beforehand. And then I have 21 edges. Well, what's 9 plus 14? That's 23. What's 21 plus 2? That's also 23. So it works out. So here on these other 2 examples, I'm giving you three-dimensional objects, but you can't, there's no dashed lines in the back to see, to show you what's going through the object. But so I tell you there's 5 faces and 6 vertices. Well, 5 plus 6 is 11, right? So I just need to figure out the number of edges plus 2. So you could do 11 minus 2, and that's 9. Or I just think, well, 9 plus 2, that's also 11. So that's how I did that. Faces and vertices, 6 plus 8, that's 14. 12 plus 2 is also 14, or 14 minus 2 is 12. So that's how I arrived at 12 edges. Okay? And now we're going to go over cross sections. So a cross section is if you sliced into a three-dimensional object, what would that slice on top look like? So three-dimensional objects are comprised of a whole bunch of two-dimensional objects just all stacked together. If you got a whole bunch of rectangles and stacked them on top of one another, you get a rectangular pyramid, for example. So on this first one, you could see in darker gray that makes a rectangle if you cut into this star, but more specifically, if you cut into it, you see like it's making a triangular prism. So the base of that is a rectangle. If you cut into a cone, you make a circle. Actually, you could say at this angle, you could say this is an ellipse. Now that I think about it, if you cut into it flat, perfectly flat, that's a circle. If you cut into it diagonally, it makes an ellipse. So I'm just going to say circle or ellipse depending on your perspective. This one is diagonally, and an ellipse is like an oval circle. Okay, so a triangle is cut into a triangular prism. You cut into it, you can clearly see that triangle. The next one is kind of confusing because it's hard to visualize, whereas these you had shaded a shaded area to use for reference. But if I cut into this, it looks like a bowl, or it's half a sphere really. If I cut into it horizontally, I get a circle. I've just formed a circle on top. Now if you cut into it vertically, well then I'm looking at a semicircle. You know, I'm looking at this, but it's all filled in. Alright. On a cone, if you cut into a cone, well, straight up or side to side horizontally, you would get a circle or an ellipse, like I said before. And then if you cut into it vertically, it would make a parabolic shape. And then it's basically half an ellipse if you want to think about it like that. Yeah, I just called it a parabola. I wasn't sure what else to call it. If you have something, a better answer than I do, let me know, and hey, maybe it is right. So if I cut into this cylinder flat horizontally, that makes a circle on top. You can see that by the bases. And if you cut it straight up and down, you make a rectangle. Now again, that one's kind of hard to visualize, but think of it like you're looking at it straight on. Like you can't see the top or bottom, so you don't know it's curved behind it. You would just see 4 corners, and those 4 corners would make a rectangle. The last one, if you cut it straight across, you're looking at a triangular cross section, and you can kind of cheat on that by just looking at the bases. And then going at it straight up and down, yeah, I would have to say that would make a rectangle as well. Okay, and that's it for the notes. It's a short section, and yeah, until next time, goodbye everyone.